Welcome to Helm of Science. So, as we know that the joint entrance exam has just ended, so that doesn't mean that we should not practice the questions, because there are some other exams that are also equally important. So, in order to keep that practice going, you must need to practice and solve the year questions. Okay, so on that respect, we today will discuss thermochemistry. This is also a very important topic. Apart from thermodynamics, there is a separate part, that is thermochemistry. Here, basically, the questions that come are generally based on some numericals. Okay, based on some formulas, you have to apply the formulas and have to solve the problems. Okay, so today we will discuss on this topic. So let's get started. So the first question is, the enthalpy of sublimation of iodine is 24 calorie per gram at 200 degrees Celsius. Okay, if the specific heat of iodine solid and iodine vapor are 0.055 and 0.031 calorie per gram per Kelvin respectively, then what you have to find out? You have to find out the enthalpy of sublimation of iodine at 250 degrees Celsius. Okay, so the first question here, we have to sublimation is the process here. So iodine solid will be undergo sublimation to form iodine gas. So specific heat of iodine, specific heat of I2 solid, this is given as 0.055 calorie gram inverse Kelvin inverse. Okay, similarly specific heat of I2 gas is also given as 0.031 calorie per gram per Kelvin. Okay. Next, enthalpy of sublimation of iodine, that is delta H1. H1 is given as 24 calorie per gram. Okay. Now T1, the temperature is given as 200 degrees Celsius. 200 degrees Celsius. That is equal to 473 Kelvin. And T2 is also given to you as 250 degrees Celsius. That is 273 plus 250, that is equal to 523 Kelvin. Okay, so these are the information that are provided. Okay, so but we have to find out the enthalpy of sublimation of iodine. That means the delta, the H2 value for iodine gas, that is, or iodine vapor, that we have to find out here. Okay, now in that aspect, we know when the amount of heat involved in a system at constant pressure, we can apply delta H, that is equal to Cp into delta T. Okay, Cp into delta T, right? So what is Cp? Cp is the specific heat at constant pressure. Okay, the specific heat of constant pressure, it is given for iodine solid as well as iodine vapor. Now what we have to do, we have to put the values. So delta H means H2 minus H1, and Cp here, Cp is into delta T means T2 minus T1. Okay, now we have to find out we have to find out H2, that is enthalpy of sublimation. So what will we get? H1 plus Cp into T2 minus T1. Okay, now H1, what is the value of H1? We know it is 24 plus Cp, specific heat. Specific heat in this case for the sublimation of iodine will be equal to how much? It will be equal to the specific heat of iodine vapor minus specific heat of iodine in solid state. Okay, that will be their specific heat of sublimation, what we call. Okay, so 0.031 minus 0.055 into T2 minus T1, that is 523 minus 473. Okay, so if you calculate all these things, calculate this entire thing, it will be 24 plus minus 0.024 into 50. Okay, calorie, gram inverse, Kelvin inverse into Kelvin. So this Kelvin will be cancelled out. So we will be left with 24 minus 1.2, and that is equal to 22.8 calorie per gram. So this will be our answer. That is, this is the enthalpy of sublimation of iodine at 250 degrees Celsius. Right? I hope all of you get this. Next. Next, there are three equations that has been given here. 1, 2, 3. So based upon the above thermochemical equations, you have to find out which of the following algebraic expression or algebraic relationship is correct. Okay, so there are four options. So what we need to see here is equation 1. It is carbon plus O2. This is giving us CO2. Okay, and its delta enthalpy of standard enthalpy of reaction is X kJ mole inverse, that is kilojoule per mole. Next is carbon, that is graphite, plus half O2. This gives you CO. Okay, CO. Here is it is in gaseous state. Here the enthalpy, standard enthalpy of reaction is Y kilojoule per mole. Okay. Number 3, CO plus half O2. This will give you CO2. This is also in gaseous state. And for this, the enthalpy of reaction is Z kilojoule per mole. Okay, so this is the thing that has been provided. Now, if you see carefully the options here, various types of options are given: y equal to z minus x, x equal to y minus z, and all. So from here, how can you frame? I mean, how will you arrange these two equations in order to get the third one? Okay, so if you look at equation 2 and equation 3, if you add these two equations, okay, so if you add these two equations, what will you get? You will get C plus half O2, and in the in the third reaction also half O2 term is there. So both of them will be added up to form O2. I think this much is clear to you. Okay, now you can see here that this CO and this CO are in the opposite side, so this will be cancelled. Okay, and carbon is left in the LHS, and if you put the arrow, you will get CO2. So this is exactly the first equation that has been provided. So what we can see here is, if we arrange equation 2 and 3 by addition, what we are getting? We are getting equation 1. Okay, so this is how you have to arrange the equations in order to get the correct expression, correct algebraic relation. So what we have got? We have got equation 3 equal to equation, I'm very sorry, equation 1, that is equal to equation 2 plus equation 3. So just you have to put their enthalpy values. So you will get X equal to Y plus Z. So this will be the algebraic relationship between them. So according to this, which option will be correct? Option D is the correct answer. Okay, option D. All right. Moving on to the next question. The heats of combustion of carbon and carbon monoxide are minus 393.5 and minus 283.5 kilojoule per mole respectively. The heat of formation of carbon monoxide per mole is. We are given four options, right? So at first what we have to write down the heats of combustion of carbon and carbon monoxide separately. So first of all, we will write the combustion reaction for carbon. So carbon solid, it reacts with oxygen and it will undergo combustion to form CO2. Okay. Here the delta H value is given. How much it is? It is minus 393.5. Okay. Minus 393.5 kilojoule per mole. Next, we have to write down the combustion reaction for carbon monoxide. So carbon monoxide, CO plus half O2. Okay. So this will give us CO2 again. Yes. And its delta H value is again equal to minus 283.5 kilojoule per mole. Right? Okay. So if I put this as equation 1, the first one as equation 1 and second one as equation 2. Okay. Now what can I do? We have to find out the heat of formation of carbon monoxide. Okay. That means we have to find an equation where carbon monoxide is forming. So how can we do that? We can do it by subtracting equation 2 from equation 1. If I do this, then what will happen? See, if I subtract equation 2 from equation 1, what we will get? We will get this CO2 and CO2. This will get cancelled for sure. Okay, CO2 and CO2 will get cancelled. This one and this one will get cancelled. So what we will get? We will get C solid plus half O2. Okay, C plus half O2. This will give you CO. Okay, because this oxygen minus half O2. This will give you half O2. 1 minus half is half. So hence we have framed the heat, the formation of carbon monoxide from carbon and oxygen. So what will be the value of their heat of formation? Heat of formation of CO, comma, delta H. So delta H will be equal to how much? It will be equal to minus 393.5 minus 283.5 mole inverse. Okay, just I have done 1 minus 2 equation. So this will give you minus 393.5 plus 283.5 kilojoule per mole. Now if you solve this, you will get minus 110 kilojoule per mole. Check your option which is correct. Minus 110.5. So option C will be the correct option. Okay. In this way, you have to arrange the equations in order to find your desired result, right? Okay. So this was our third question. Now moving on to our fourth question. So the fourth question is delta H vaporization, that is enthalpy of vaporization. This has been provided. It is equal to 30 kilojoule per mole. This is given to us, and also the entropy of vaporization, that is delta S vaporization. This is given to us 75 joule mole inverse Kelvin inverse. Okay. So what you have to find out here, you have to find out the temperature of vapor at 1 atmosphere. Okay, so this is a very simple formula that you have to apply here. You have to find the temperature. Okay, so for finding the temperature of the vapor, comma capital T, you just have to apply this simple formula, delta H vaporization by delta S vaporization, delta S vaporization. Because you know delta H equal to T delta S, so T will be equal to delta H by delta S vaporization. So delta H vaporization is equal to how much? Delta H vaporization is equal to 30 kilojoule per mole. So 30 into 1000 joule mole inverse. Okay, you have to convert kilojoule into joule divided by 75 joule per mole per Kelvin. So if you solve this, you will get 400 Kelvin. So 400 Kelvin will be the temperature of the vapor. Okay, so according to the option, it is option A. Option A will be the correct answer. This is a very simple problem. You just have to remember this formula. Delta T is equal to delta H vaporization by delta S vaporization. Okay. Now coming on to the fifth problem. The fifth problem says the standard enthalpy of combustion at 25 degrees Celsius of hydrogen, cyclohexene and cyclohexane are minus 241, minus 241, minus 38,000 and minus 39,000. I'm very sorry, minus 21, minus 3800 and minus 3920 kilojoule per mole respectively. You have to find out the heat of hydrogenation of cyclohexene. Okay, you have to find out the heat of hydrogenation of cyclohexene. Okay, so first of all we need to write this. We know is cyclohexene. Okay, when it reacts with hydrogen, what it will form? It will form cyclohexane. Okay, this is cyclohexane and this is cyclohexene. Undergoes reduction to form cyclohexane. Okay, so for cyclohexene, the value of enthalpy of combustion is minus 3800 kilojoule per mole. For hydrogen, it is minus 241 kilojoule per mole. Okay, and for cyclohexane, it is minus 3920 kilojoule per mole. Okay, this is given to us. Now what we have to do, we have to find out the heat of hydrogenation of cyclohexane. Heat of hydrogenation of cyclohexane, that is delta H. Okay, heat of hydrogenation of cyclohexane. So there is a formula, summation of delta H combustion, that is enthalpy of combustion of reactants minus summation of delta H combustion of products. Okay, this is the formula to find out the heat of hydrogenation of a product molecule. Here it is cyclohexane, right? I mean cyclohexene, I'm very sorry, cyclohexene. It is cyclohexene. Okay, so reactants minus products. By this you can find out the heat of hydrogenation of cyclohexene molecule. Okay, so in the reactant part you can see that there is cyclohexene and hydrogen. Okay, so minus 3800 minus 241. Okay, minus and for the products, this is cyclohexane, so minus 3920, and this is entirely given as kilojoule per mole. So if you solve this, you will get minus 121 kilojoule per mole. So this is your heat of hydrogenation of cyclohexane molecule. Okay, this will be your answer. This is one subjective type of question. No options were given there. So you just have to find out the answer and just mention it. Okay. Now we will move on to our last question for today's class. The standard heats of formation of CCl4, H2O, CO2 and HCl are minus 25.5, minus 57.8, minus 94.1 and minus 22.1 kilocalorie per mole respectively, and the temperature is 298 Kelvin. So you have to find out the delta H naught, standard enthalpy change for the reaction. Okay, so the reaction that has been given is CCl4 plus 2H2O, and the product is CO2 plus 4HCl. This is given to us. Okay, I'm writing down their heats of formation values. Just a minute. Heat of formation values. Okay, for CCl4 it is minus 25.5. For H2O it is minus 57.8. For CO2 it is minus 94.1, and lastly for HCl it is minus 22.1. All are in kilocalorie per mole. Kilocalorie per mole. Okay. Now, for determining the delta H naught, standard enthalpy change for the reaction, what you have to do? You have to perform this formula. Summation of, just a minute, summation of delta H naught formation of the product molecules minus summation of delta HF of the reactants. Okay, so here you can see for the product molecules, CO2 is 1, so minus 94.1. Okay, minus 94.1 plus, here how many HCl molecules are present? 4. So 4 into 22.1. Okay, this is the product part minus, now we will mention the reactants. For CCl4 it is minus 25.5 plus 2 into minus 57.8. Okay, so this is the formula to find out the standard enthalpy change for the reaction. So if you solve this entire thing, I'm not solving here. If you solve it, you will get minus 41.4 kilocalorie. This is also one subjective type of question. You just have to find out the answer. So here you have to remember this formula, that is delta H naught equal to heat of formation of the products minus summation of the heat of formation of reactant molecules. And once you solve, you will get the answer. Okay, so this much for today. We will have another session on thermodynamics and thermochemistry as well, where we will discuss some other questions, some other important questions that came in your joint entrance exams. Okay, so I hope all of you have understood the concepts of today's class, and if you did, then give it a like and share among your friends so that they can also be able to experience our I mean, the process, the classes. They also be able to watch the classes and subscribe our channel Helm of Science from for more of such videos. Okay, so until we meet in the next class, stay safe and stay healthy and have a good day. Thank you.